Okay, I hope I'm audible to all the students who are attending this lecture of Intermediate Macroeconomics Part 2. Okay, we continue with our lectures on economic growth. We continue with our lectures on economic growth. And in the last lecture, we were doing the Solow model. We had started with the Solow model of economic growth in the previous lecture. Okay, and quickly revising it with all the students, all of you recall we had talked about the steady state. We had talked about the steady state in the Solow model. Okay, so if you all can recall, when we talk about capital stock per worker, remember the Solow model assumes constant returns to scale production function. So we had converted our entire analysis in per worker terms, if you can recall from the previous lecture. And then we had said that when we talk about capital stock per worker, there are two factors influencing the capital stock. Two factors influencing small k, which is nothing but my capital stock per worker. Now, guys, what are these factors? First factor, if you all can recall, was investment. It increases the capital stock per worker. Okay, and second factor was depreciation. Second factor was depreciation, which reduces the capital stock per worker. Okay, and then we had said that what is change in capital stock? Change in the capital stock is equal to investment minus depreciation, because investment is the amount by which new capital is added in the economy. Depreciation is the amount by which the existing capital stock is wearing out. Okay, so we had written change in capital stock per worker, change in small k, is equal to investment I minus depreciation is happening at the rate delta every year, so minus delta k. And all of you can recall, guys, investment itself was equal to savings. What is savings, guys? The savings rate times the production function, which is my output. Savings rate into output gives me savings, and investment is equal to savings. So I can write change in capital stock per worker is equal to investment, which is SF of k minus delta k. And then we had said in steady state, our change in capital stock per worker should be equal to 0, which implies SF of k minus delta k should be equal to 0, which implies SF of k should exactly be equal to delta k. Okay, so we had said that therefore, what was the steady state condition? K star is the steady state. It is the steady state level of capital stock per worker. It is the steady state level of capital stock per worker at which our savings SF of k star exactly equals our depreciation delta k star. So guys, this was the steady state condition which we had done in the previous lecture of economic growth. Now let's do a numerical. Let's look at a numerical which clarifies or clears up the steady state condition which we had done. Okay, so let's look at a numerical example. Let's look at a numerical example. Okay, so suppose the production function is given by y is equal to k to the power half L to the power half. Suppose guys, this is the production function given to us. And the question also tells us, suppose 30% of the output is saved. Suppose 30% of the output is saved and 10% of the capital stock, 10% of the capital stock depreciates every year. This is the data given to us. The question asks us find the steady state level of capital stock per worker. Find the steady state level of capital stock per worker. Okay, so we are asked to find the steady state level of capital stock per worker and output in the steady state. So guys, let's solve this question. Step 1, we are given the production function k to the power half L to the power half. Step 1, we convert this into in per worker terms. So step 1, convert the above production function in per worker terms. Now guys, if it was already given to you in per worker terms, then step 1 was not required. But in this question, it's not given to you in per worker terms, so you will convert it in per worker terms. How will I convert it? Divide both sides by L. Y by L is equal to k to the power half L to the power half upon L, which implies y by L is equal to k to the power half upon L to the power half, which implies y by L is equal to k by L to the power half, which implies, now guys, what is y by L? Small y. What is k by L? Small k to the power half. So you can see we started with the production function which is given to us. We divided both sides by L. We have got the production function in per worker terms. Y is equal to small k to the power half. Now guys, in the question, what else is given to us? We are given that 30% of the output is saved. So my savings is 30%, which is 0.3. We are given that 10% of the capital stock depreciates every year. So delta is 10%, which is 0.1. Okay, what is the steady state condition? So all of you can recall, at steady state, S f of k star is exactly equal to delta times k star. What is S? 0.3 times f of k star will be k star to the power half. This is what, guys? This is nothing but f of k. So f of k star will be k star to the power half equal to delta is 0.1 times k star. So this implies 0.3 times k star to the power half is equal to 0.1 times k star, which implies 0.3 divided by 0.1 is k star divided by k star to the power half, which implies 3 is equal to k star to the power half, which implies, guys, what is my steady state level k star? 3 ka square, which is 9. So at the steady state level, k star is equal to 9. So once I've got k star, can I find output? What will my output be? Output per worker will be what? So therefore, y star will be k star to the power half, which will be 9 to the power half, which will be 3. So I hope all students have understood this numerical example. We were given the production function, we were given the savings rate, depreciation rate. How will we find the steady state level of capital stock per worker? First, convert the given production function in per worker terms. Apply the condition of steady state S f of k star, which is my investment is equal to depreciation, which is delta k star. S is 0.3, f of k star is k star to the power half. Delta is 0.1 times k star. Solve for k star, you get k star as 9. Plug it back in f of k, you get y star as 3. So I hope all students have understood this numerical example. Okay. Now guys, let us see what are the factors which affect growth in the Solow economy. We have talked about steady state. We have seen what will be the output and capital stock in the steady state. But now let us see what are the factors which will affect growth in the Solow economy. Okay, so let's come to the lecture note. Okay, so all of you can see the lecture note on your screen. So let's start with how savings affect growth. Because all of you can recall from the previous lecture that capital stock per worker will determine how much will be produced, but savings will determine how that output produced will be allocated between consumption and investment. Because all of us know in the Solow economy, demand is coming from households, which is consumption, and firms, which is investment. So let us see how savings in the Solow economy affect growth. So you can see the diagram on your screens. On the horizontal axis, we have the capital stock per worker, and on the vertical axis, we measure investment and depreciation. You can see the initial savings curve. Suppose my savings rate is S1, then my savings curve is this S1 times f of k. My depreciation line is delta k. So guys, initially my steady state is given by K1 star. So in the above diagram, economy is assumed to be in the steady state with the savings rate S1 and capital stock K1 star. Now suppose the savings rate goes up. Suppose the savings rate increases from S1 to S2. So suppose the savings rate increases from S1 to S2. What will happen to the savings curve, guys? The savings curve will shift up. You can see in the diagram, the savings curve is going to shift up for every level of capital stock per worker. The economy can now save more because the savings rate has gone up. So now what will happen? So if you continue to remain at K star, now at K star, my investment now is this much, but my depreciation is this much. So at K1 star, now my investment has become more than depreciation. This will cause the capital stock per worker to rise till we reach the new steady state level of capital stock per worker, which is K2 star. So let's read the explanation once. So when the savings rate increases from S1 to S2, the savings curve shifts upwards. At S1 and at the initial capital stock K1 star, now my investment exceeds depreciation. So you can see this line immediately after the savings rate increases, investment is higher than depreciation. When the savings rate was S1, then at K1 star, investment was equal to depreciation. That is why K1 star was the steady state level. But the moment your savings rate went up at K1 star, now investment becomes more than depreciation. As a result, capital stock will gradually rise till the economy reaches the new steady state, which is K2 star. You can clearly see that K2 star has a higher level of capital stock and output as compared to the old steady state. That means an increase in the savings rate will cause the level of capital stock per worker and output to rise. So what do we learn? You can see the conclusion on your screens in caps. Okay. If the savings rate is high, the economy will have a larger capital stock per worker and a higher level of output in the steady state. However, if the savings rate is low, the economy will have a small capital stock and a low level of output in the steady state. Now, guys, very important thing I am discussing with all of you. When we talk about savings, savings will only cause growth temporarily, which is the note you can see on your screens. Higher savings will cause faster growth in the Solow model only temporarily. That means, guys, when savings rate goes up, growth will happen in the Solow economy only when you reach the new steady state. Once you have reached the new steady state, growth will stop. That means if I come back to the diagram, you can see the diagram on your screen. When the savings rate goes up, okay, when the savings rate goes up, then at K1 star investment exceeds depreciation. So economy will grow. But the moment you come back to K2 star, which is the new steady state level of capital stock per worker, at this new steady state level of capital stock per worker, now the growth will stop. So guys, savings will cause growth so far as you are moving from K1 star to K2 star. Once you have reached K2 star, growth will stop. Because at K2 star, the new capital added by investment will exactly be offset by depreciation. So at K2 star, there will be no change in capital stock per worker. And at K2 star, since there will be no change in capital stock per worker, there will be no change in output. No change in output means no growth. So understand this, guys. Savings will cause growth only temporarily when you move from the initial steady state to the new steady state. But once you have reached the new steady state, growth will not happen. So you can see what is savings actually doing. Savings is causing only a level effect. So level effect means what? The level of capital stock per worker has gone up. The level of output per worker has gone up. The level has gone up, but the growth has not gone up permanently. Growth has only gone up temporarily. So can we say that savings in the Solow economy can permanently lead to growth? No. In the Solow economy, savings cannot permanently cause growth of output and capital stock per worker. Savings can only cause growth temporarily when you are in the transition phase from the initial steady state to the new steady state. But the moment you reach the new steady state, growth stops. So savings in the Solow economy will only cause a level effect. So let's read this note. So higher savings leads to faster growth in the Solow model, but only temporarily. An increase in S raises the growth only until the economy reaches the new steady state. That means the phase of transition. If the economy maintains high savings rate, It will maintain larger capital stock and a higher output level, but will not maintain a larger growth rate forever. This line is very, very, very important. This line is very important. So it's highlighting what? It is highlighting that savings cannot permanently increase growth in the economy. So higher savings rate, this line is also very important. Higher savings rate is said to have only a level effect, because only the level of income per person and not its growth rate is influenced by savings rate in the steady state. What is savings doing, guys? Savings is just causing the level of output per person and the capital stock per person to go up. It is not permanently causing growth in the economy. So when I say that higher savings rate has a level effect, if I just come to the whiteboard to explain this, okay, when we say that higher savings rate, or when we say that the savings rate only has a level effect, it only has a level effect in the Solow economy and not the growth effect. What does this mean? This means that an increase in the savings rate will increase the level of capital stock per worker and the level of output per worker. But an increase in the savings rate will cause growth only temporarily as transition happens, as the transition happens from the initial steady state, as the transition happens from the initial steady state to the new steady state. Once the economy reaches the new steady state, once the economy reaches the new steady state, growth will stop. So if someone asks you, can savings cause permanent increase in growth? No. It will only cause growth temporarily during the phase of transition between the steady states. But once you have reached the new steady state, now in the new steady state, you can clearly see in the new steady state, the level of capital stock per worker is higher. In the new steady state, the level of output per worker is higher. But in the new steady state, growth is still the same. There is no growth in the new steady state. Okay, so let's come back to the lecture note. Hoping students have understood this. Okay, so now guys, after having understood the impact of savings in the Solow economy, let us also talk about another very important concept called the golden rule level of capital. Now, let's understand something. Till now, whatever analysis we have done, you all would have understood one thing, that different savings rate will give you different level of steady state capital stock per worker. As I keep on changing the savings rate, I will get different levels of steady state K stars. Now, out of all the steady state level of capital stocks, we need to choose that steady state level of capital stock which is maximizing the well-being of the individual. And when I say maximizing the well-being of the individual, it means maximizing consumption. So let's give it a read first. When choosing a steady state, the policymaker goal is to maximize the well-being of the individuals who make up the society. Now, when we talk about individuals in the society, individuals do not care about the amount of capital in the economy or even about the amount of output. Firms care about capital. When we talk about individuals in the society, they don't care about capital. All what they care about is the amount of goods and services they can consume. So this line is very important. Individuals care about how much goods and services they can consume. So a policymaker would want to choose that steady state level of capital stock per worker which maximizes consumption. And that steady state level of capital stock per worker is called the golden rule level of capital, which we denote by K star gold. So students need to understand this. If I come to the whiteboard to explain this concept to you, okay. So understand this, guys, that different savings rate gives us different levels of steady state capital stock per worker. As I keep on changing the savings rate, I will keep on getting different levels of steady state capital stock per worker. Now, out of all the steady states, we need to choose that steady state level of capital per worker which maximizes consumption. This steady state level of capital per worker is called the golden rule level of capital. It is called the golden rule level of capital, denoted by K small k. This is small k, guys, denoted by small k star gold, subscript gold. Okay, so hoping that students have understood this particular note. If I come back to the lecture note, let us now derive the golden rule level of capital. So now let's come to the maths of it. So all of us know that income in the economy is consumed or invested. Y is equal to C plus I. So what is C, guys? Our C will be nothing but Y minus I. Okay. We had done this national income identity previously as well. Demand is coming from consumption and investment. So consumption is income minus investment. Now the steady state output per worker is F of K star. K star is the steady state level of capital stock per worker. Further, we know that in the steady state, delta K is equal to 0. Change in K is equal to 0 in the steady state. So investment is equal to depreciation. Okay. So guys, what is C star now? If I talk about consumption in the steady state, what is consumption? So consumption in the steady state is denoted by C star. In the steady state, output is equal to F of K star. In the steady state, investment is equal to depreciation. So this equation I can write like this in the steady state. Guys, I'm revising it again. All of us know Y is equal to C plus I. So C I can write as Y minus I. Now in the steady state, we want to see what is our consumption in the steady state. So in the steady state, consumption C is equal to C star. In the steady state, output is equal to F of K star. In the steady state, investment equals depreciation. You know that. That means my investment I is equal to delta K star in which is your depreciation. So I can write C star is equal to F of K star minus delta K star. So this is my consumption in the steady state. This equation is giving us what? This equation is giving us consumption in the steady state. Consumption in the steady state. Now guys, you can clearly see that an increase in the steady state capital stock has two opposing effects on the steady state consumption. When you talk about K star, an increase in K star has two opposing effects on consumption. You can see an increase in K star means more output, and more output means more consumption. But an increase in K star also means more depreciation. An increase in K star means more depreciation reduces consumption. So guys, if you look at both the opposing effects, okay, you can see on your screen, more capital means more output. More capital also means more output, which must be used to replace the capital that is wearing out. That is why you can see, guys, that K star is affecting C star positively also and negatively also. Because more capital stock per worker means more output means more consumption, but more capital stock per worker also means more depreciation. That means more output will now be used to cover up for the depreciation, so lesser output will be available for consumption. So I can say K star has two opposing effects on steady state consumption. Okay, it increases the consumption via output, it also reduces the consumption via depreciation. So hoping students have understood this. Okay, let's move forward. Now guys, we can see the diagram. Let's look at the diagram now. So now what are we measuring on the horizontal axis? Now on the horizontal axis, we are measuring the steady state level of capital stock per worker. That means, guys, now on the horizontal axis, we are not measuring small k. Now on the horizontal axis, we are measuring K star. It means all the capital stocks on the horizontal axis are already steady states. On the vertical axis, what do we have? On the vertical axis, we have output and depreciation. So guys, you can clearly see this is my steady state output curve, F of K star. F of K star means steady state output for different levels of steady state capital stock per worker. So again, I am revising it. In this diagram on the horizontal axis, we don't have K, we have K star. It means all capital stocks on the horizontal axis are already steady states. We have to choose among the steady states now. In the previous diagram, from the capital stock per worker, we were choosing the steady state. Now from all the steady state level of capital stock per worker, we are choosing the golden steady state level of capital stock per worker. So you can clearly see this is my output curve. This is my savings curve as f of k star. This is my delta k star line. Okay. So if we give it a read, the above diagram graphs the steady state output and depreciation as a function of k star. What is steady state consumption, guys? If you all can recall, steady state consumption is nothing but the gap between output and depreciation. You can see the C star is equal to f of k star minus delta k star. So if I speak this in words, my steady state consumption is the difference between the output and depreciation. So if you look at the diagram, we want to maximize consumption means what? If we want to maximize consumption, we want to maximize the gap between the output and the depreciation line. And you can clearly see in the diagram that the gap between the output and the depreciation line is maximum at K star gold. You can see this gap is maximum, guys, at K. So this is my golden rule level of capital stock per worker. Because by definition, if you can recall, K star gold is that steady state level of capital stock per worker at which consumption is maximum. And we just saw consumption is the gap between output and depreciation. For consumption to be maximum, the gap between the output and depreciation should be maximum. And you can see it's happening only at this point, K star gold. You can see the gap is maximum. Okay, so I hope students have understood this particular case. Okay, so you can clearly see if you choose a steady state level of capital stock below K star gold. Suppose, guys, I choose. So first of all, let me erase this. Suppose I choose a level of capital stock per worker below K star gold. Now, guys, if I choose this, what is happening? So if I increase the capital stock, you can see that output is increasing faster than depreciation. Output is increasing faster than depreciation. If you look at the capital stock below the golden rule level. How can I say that, guys? Very simple. You can see at K star, draw a tangent on the output curve. So if I draw a tangent, it's like this. You can see at K1 star, the slope of the output is more than slope of the delta K star line. This simply means that increasing K star will increase output faster than depreciation. And similarly, guys, consider a level of capital stock above K star gold. Suppose I take this case, K2 star. At K2 star, you can clearly see now the slope of the output curve. If I draw a tangent here, it's becoming flatter. It's becoming flatter than the delta K star line. This means if I now increase the capital stock beyond K2 star, output will increase less than depreciation. So if I quickly give it a read, you can see this written in the paragraph form as well. Okay, so you can clearly see now, if the steady state capital stock is below the golden rule level, an increase in the capital stock raises output more than depreciation. And since output increases more than depreciation, my consumption increases. You can clearly see in this case, the production function is steeper than the delta K star line. so that increasing the capital stock K star will increase consumption. On the other hand, if the steady state capital stock is above the golden rule level, that means K2 star in the diagram, an increase in the capital stock reduces consumption. Why? Because output is now increasing less than the increase in depreciation. Why? Because production function is now flatter than the delta K star line. So in this case, an increase in K star will reduce your consumption. So at the golden rule level, you can clearly see that the production function and the delta K star line have the same slope and consumption is at its maximum. So if we come to the diagram, guys, you can clearly see this. At K star gold, okay, at K star gold, slope of the production function and slope of the delta K star line are exactly the same. You can see that it's parallel to the delta K star line. Below K star gold, you can see the production function is steeper than the delta K star line. So increasing the capital stock will increase consumption because output will increase faster than depreciation. On the other hand, at K2 star, the production function is flatter than the delta K star line. So if you further increase the capital stock, if you further increase the steady state capital stock, output will increase but less than the increase in depreciation, which will cause consumption to fall because consumption is the difference between output and depreciation. That means only at K star gold, when the two slopes are the same, slope of the production function is exactly equal to slope of the delta K star line, at K star gold, your consumption is maximum. Now guys, what is the slope of the production function? What is the slope of the production function? The slope of the production function is nothing but marginal productivity of capital stock per worker. We had done this in the previous lecture of Solow model. MPK denotes the slope of the production function, marginal productivity of capital stock per worker, and the slope of the delta K star line is delta. The slope of the delta K star line is delta. So you can clearly see at K star gold, at the golden rule level of capital, slope of the production function exactly equals the slope of the delta K star line. So my golden rule condition is given by MPK equal to delta. So I can say that at the golden rule level, the marginal product is exactly equal to the depreciation rate. So guys, this is my golden rule condition which we have derived today in the lecture. In the last lecture, we had talked about steady state, how the condition for steady state level of capital. In this lecture, we saw that among all steady state level of capital, we have chosen that steady state at which consumption is maximum. And the condition for it is given by slope of the production function equal to the slope of the delta K star line, which implies MPK is equal to delta. So guys, this is where I intend to stop in this particular lecture. In the next lecture, we will solve a numerical based on the golden rule level of capital. So I hope all students have enjoyed this lecture. Any doubt? You can unmute your mics and ask, or you can call up or mail me your doubts at divineschoolofeconomics@gmail.com. We will continue with our lectures on Solow model in the next lecture as well. So this is where I stop.